All right, welcome to the second class of Mac 124 CNC Milling 1. What did we learn today? Well, we reviewed pages 1 through 28 in your Haas programming manual that went over the basics of CNC programming. Cartesian coordinate system, absolute versus incremental, blah, blah, blah. You all read that for homework. I also went over the paperwork that we did last time, which was the we used this coordinate form, and then we used our first project management form, the mill coordinate planning form, to say where those hole locations were. All right, we checked on all that. Then we discussed that for quite a bit, but then we went right into project management overview. I showed you the flow of a part through the shop, through the five different project management life cycles: initiation, planning, execution, measure control, and then closing. I especially spent a lot of time on initiation because I had you do an initiation of your own for this new project that we're going to be doing for project 1. I wanted to emphasize in the project management flow chart that we want nice smooth flow through the shop, not as fast as we can go. Speed is not the object, but a nice smooth flow so that you don't have to go back and forth and chase yourself or chase your tail or anything like that. We want to go in just one after the other and get things done. In the end, this will save time and make you a better machinist who makes fewer mistakes. All right. Then the next thing we covered was the Haas programming manual, pages 28 to 41, which dealt with the motion codes. There are only 4 of them: G00 rapid, G01 linear at a feed rate, G02 and G03 are circular interpolation. I want you to refer to them that way. Use those terms to refer to them. The book has a very good format for explaining how each of these codes is programmed and how the codes are written. I also said that I want you guys to follow my formats. So going forward, I'm going to ask you to write the lines of code out a very particular way, and I want to see them that way every time. I gave you page 41 for homework, and I'm planning on doing that as well. I'm going to do that right along with you. The other things that we learned today was a vector is a direction and a distance. The definition of tangent is one point of contact relative to a curve or surface. The best example for that is drop a bowling ball on the floor. How many points of contact does the bowling ball make with the floor? So I used the vector here to explain a little bit about I and J programming for arc circular interpolation moves. The I and the J are vectors from the starting point to where the arc is swung from. That's really all you need to know. We're going to program a move from here to here, but the I and the J are taken from the starting point to the swing point, the direction and distance of that. Then the circular interpolation move ends up at these X and Y locations. I explained that I and J stand in for X and Y. Also, here is an example of a point of tangency where a circular move goes from G03 to G02. At this point of tangency, we have one point of contact relative to these 2 circular lines. If these were complete circles, that's the one point of contact for those 2 circles. I also over here, I showed you the file naming convention that we're going to use throughout the course, and to make sure that you save your computer files in 2 places, and that you have a good folder and good organization of your computer files. It'll save you a lot of aggravation. We'll see you Thursday.